Okay, so we have a barbell, and this barbell consists of two balls with known masses. Each mass is 0.9 kilograms, and it's both connected by this low mass rod. This rod right here. Now, the barbell slides across a low friction icy surface, spinning as it moves. As you can see, it spins. It's spinning, but still it's moving in a direction. The distance between the centers of the balls is 0.29 meters, and the speed, or the velocity, of the center of mass is 0.36 meters per second. And the barbell makes one complete revolution in 5 seconds. So one revolution in 5 seconds. Now what we want to find is the translational kinetic energy of the barbell. So K-trans is what we're looking for. And the translational kinetic energy is simply equal to 1/2 the mass times the velocity squared. And we can plug in all our numbers, and what we would get is 0.116 joules. Now this is our kinetic translational energy, so as the barbell is moving this way. Now next, considering all the motion of the barbell relative to the center mass, what we're looking for is what is the speed of one of the balls as it rotates around the center of the barbell. Now to find this, we have to do a little bit of work. So we're looking to the velocity, the rotational velocity. And the rotational velocity is equal to the distance times pi over seconds. And the seconds is seconds per revolution. That's what we need to. So if you're given 2 revolutions per odd number of seconds or something like that. But since we have 1 revolution per 5 seconds, that's what we're going to use. We're going to use 5 seconds. If this was 2 revolutions per 10 seconds, then still would be 1 revolution per 5 seconds. Okay, so plugging it in, again, pretty simple. You'll get another number, which is 0.18 meters per second. And you can check this meters per second because this is a constant, has no units. The distance is in meters and then seconds. So, now, the next thing we want to look for is what is the rotational kinetic energy of the barbell. So as this barbell is rotating, what is its energy? And this is going to be the kinetic energy that is associated with the motion relative to the center of mass. So, K rotational, and we do have to do work for this, it's equal to 1/2 the moment of inertia times the angular velocity squared. So, how do we find the angular velocity and how do we find the moment of inertia? So, I is simply equal to the mass times that distance squared. And since we have 2 masses, we're going to add the masses together. And then our distance, since we're going to do it twice, so our moment of inertia is going to be our mass times our diameter squared. And if we add both our masses together and then we divide our distance, we'll come up with 2 of our masses times our distance divided by 2 to give us this distance at the center of mass. And we are still going to square it. Working it out, you come out with the moment of inertia is equal to 0.03 approximately. Now, to find our angular speed, W, angular speed is simply 2 pi over time. And this time you have to be careful with this time. Time needs to be in revolutions per second again. Same thing as whenever you're looking for the velocity of rotation. So ours comes in revolutions per second, so we're good. So our W is equal to 1.256. Now, plugging in our W and our I into our equation, up here, K rotational is equal to 1/2 moment of inertia times our angular velocity squared. And that'll give us a K rotational equal to 0.02985 joules. Now what if you want to find the total kinetic energy of the system? How would you find that? You would simply add up your K translational, so K translational as it's moving in this direction, plus your K rotational as it's rotating. Remember, this barbell is rotating as well as moving in this direction. And that'll give you your K total. Plugging in all your numbers, you come up with approximately 0.14 joules for your K rotational.